one of the key mathematical results in my thesis was just showing that if we've got this generalization optimal learning, which is just to say that keep more options open, more possible futures open. If you scale up the selection pressures, at some point you get something mathematically equivalent to reafference. That's where you can tell the difference between intervention and observation. So that would be where there's some subject to have done something, right? Like I have a subjective experience in the sense that there is a sort of a nexus of me. When you look inside a human, you see the same sort of pattern, this self-organization, where cells are interacting to form organs, organs interact to form the organism, organisms interact to form an ecosystem. This is multi-scale competency stuff that Levin talks about. So you need the hierarchy of cells and you need this architecture thing. And if you have those, then I think that would be sufficient for consciousness. So I would argue that the current architectures that we have are incapable of supporting consciousness because they cannot.
Dr. Michael Timothy Bennett is a computer scientist at the Australian National University who went from musician to game developer to co-founding a machine learning company in London before writing an award-winning PhD thesis called How to Build Conscious Machines. He invented Bennett's razor, a new principle of intelligence that outperformed Ockham's razor by up to 500%. He's won Best Paper at the world's top AGI conference 2 years in a row and mathematically proved that cancer might be better understood as an information processing failure, not simply a genetic disease like we learned in the textbooks. Subscribe before your cells lose their collective identity and start going on side quests.
You have a super interesting reframing of cancer. That's, Mike Levin has developed this as well, as cancer is some sort of disconnection from a larger information system, a larger information structure. Talk about that for a while and explain that. I find this super interesting.
So I've got two cells, right? You could think of the cells as an abstraction layer. They form a higher level collective. That higher level collective only has a viable policy if the individual cells share an overlap. And if there's too much top-down control, or the criteria are too hard to meet, or if we bombard it with radiation or just punch it, we can really just reduce that overlap until eventually there's no overlap. And then the cells don't cease to exist. They're still pursuing their own goals. And so the mathematical result I got, and it actually formally proves that if you overconstrain the system, the cells get the collapse of the overlapping policy set, and then, they must sort of split apart and splinter into two separate collectives, or three separate collectives, or however many collectives is necessary until a viable policy is left. So, yeah, it gives a mathematical spine to the stuff that has been talked about with cancer.
Dr. Michael Timothy Bennett, why does information processing feel like anything?
Starting with the bold questions right out of the gate. Okay, well, I've got a long-winded answer to that, but I'm going to give the short version. Is it's more efficient to have the sort of representation and valuation of information happen together than it would be to have a separate representation and then attach an evaluation to it after the fact. We're kind of putting the cart before the horse when we think that we can have something completely, sort of value neutral information arise before you get a sort of evolutionarily informed set of informational representations about your world. I mean, we're evolved, which means we've kind of got a value judgment built into us, because anything which is, I call it the cosmic ort. It's like anything that the universe doesn't like gets deleted. So, yeah.
Let's try zoom in. I've been fascinated with this question. 800 million years ago, or however it is, estimates vary, of when you start evolving a system with valence neurons, when it starts interacting with its environment and gaining some sort of sense of, this is a good chemical, this is a bad chemical. There's food over here, there's a predator over here. Do you have a model in your head of how a system goes from a non-valenced system to suddenly a valence system where it can start to understand what good and bad even means and how that actually works at a system level, in that fish or whatever that organism was 800 million years ago.
I guess what I argue in the thesis is it starts even before that kind of basic level. You could think of it as like every every sort of thing. Imagine you've got some multiverse of you know state transitions one after the other, and in some universes there's one sequence of states, in other universes there's another, and you could think of every object that exists as like the set of universal states in which it is present or continues to exist. That way we can talk about existence or not without having to talk about specific objects. We've just got some things that are being deleted as the universe progresses, and some things that are not. And if and the argument I make is that if we've got we can form abstraction layers from this, get some formal results, do all kinds of interesting things. But um, the argument I put forward is that if we get a kind of stable abstraction layer, like an environment like Earth or something like that, where objects are able to grow in complexity without necessarily being deleted, because complexity is often a liability, um, then this allows for self-repair. Like a rock that self-repairs is more persistent than the same rock if it didn't. And if you've got a fairly, supportive environment, then there's enough for that phase transition to take place. You go from no self-repair to self-repair. Suddenly you've got competition between things that self-repair. And um, that would be that kind of good, bad start, at least from a agentic point of view. I guess my model kind of shoves off the good bad thing to saying the universe does it because it deletes some things and preserves other, which is kind of some people may find unsatisfying as an argument.
I I understand that from a selection perspective, but it's still not clear to me, again, that sort of jump, that sort of leap from a system that can tell something is good to a system that can't tell something is good. Do you have any sense of what that is in an information processing system?
I mean, you're asking for further down the road, not just is it doing something that is actively preserving its existence, but is making a judgment?
Yes. I guess line that some people will call consciousness, some people won't call that consciousness. It very much depends on definition. But I'm extremely interested in that line of sand from non-conscious to conscious.
Getting accurate and unbiased information from the latest scientific research is critical for my job as a science communicator. That's why for over 1 year now, I have been doing all of my scientific research with Consensus.ai. You can think of Consensus as the ChatGPT for science, trained exclusively on research papers, so it doesn't give you that hallucinated garbage like ChatGPT. Recently, I've been in love with the new deep search function they just launched. Let's try it out. So I needed to learn about brain organoids for a podcast with Philip Ball. Let's run a deep search and see how Consensus helps me understand the entire breadth of a field in literally the shortest time possible. It filters through every paper on brain organoids, giving a really nice intro summary at the top. It comes up with this really interesting question: do brain organoids model human brain development accurately? And gives me a consensus bar on the evidence. It tells you the top contributors in different fields. This is a table I love: claims and evidence. It lists out the most relevant claims to your original search and ranks them by evidence. I mean, seriously, where was this while I was in college? I think that's about 20 hours of work right there in one button click. If you're a scientific researcher, a student in college, or you're simply curious and have questions about science, then I think Consensus AI is a complete no-brainer. And the best news is that you can use my link in the description to get a whole month completely free, so there's really no reason at all not to try it out, and it really supports the channel. Thank you so much.
All right, cool. This is much more developed set of ideas than I can. So again, going back to the damn thesis, but if we sort of scale all this up, assume we've got something that's trying to persist, and when I say trying, I don't mean intentionally. It's doing things like self-repairing, moving towards food, like slime mold does this sort of thing. But slime mold is not conscious. Slime mold is just blind mold. Um, and at some point, if you increase this idea of self-organization, where you have all of, say, a group of humans is self-organizing, right? We all interact with each other, and do something like have a market that optimizes for certain goods. But the market is not conscious. The individual humans involved are the thing with the agency. Um, and when you look inside a human, you see the same sort of pattern, this self-organization, where cells are interacting to form organs, organs interact to form the organism, organisms interact to form an ecosystem. This is multi-scale competency stuff that Levin talks about, which is sort of talked about as a competency architecture. I like to think of this in terms of abstraction layers, like you get in a computer, because how we go from software to hardware. You could argue that physics is the abstraction layer below hardware, and you could apply the same idea to human bodies with cells, organs, organisms, or you could apply it to organizations like a military organization, like with squads and platoons and companies. Just scale up the sort of level at which you're looking at, like the sort of multi-scale competency architecture. If we do this with, say, a self-organizing system like a fly, right? A fly is an organism that can tell the difference between something it has caused and something it has merely observed in the world. Like if I put a fly on my shoulder and my shoulder moves, it reacts differently than if it moved, right? It's got this thing called reafference. And so one of the key mathematical results from my thesis was just showing that if we've got this generalization optimal learning, which is just to say that like you can keep more options open, more possible futures open, then if you scale up the selection pressures, at some point you get something mathematically equivalent to reafference, or in computer science, which is where I was coming from, this is equivalent to Pearl's do operator. Is where you can tell the difference between intervention and observation. So that would be where there's, some subject to know that I have to have done something, right? Like I have a subjective experience in the sense that there is a sort of a nexus of me, but it doesn't mean I'm aware of it. Like that awareness you were talking about, that I mean, other people have talked about access consciousness versus phenomenal consciousness, and that first order self, that reafference and everything. That's more the phenomenal consciousness sort of level. That's where we're getting some sensation, and there's a subject to be subject to that subjective experience of sensation of attraction and repulsion. But a fly doesn't know it's feeling pain; it just reacts. If we look at this access consciousness idea that people like Ned Block have talked about, that's where I can tell you I'm feeling pain. And so I am sort of predicting your prediction of me, modeling what you think of me, and then taking an action that is going to alter your prediction of me based on my prediction of your prediction of me. And this ties into a theory of meaning called Grassian theories of meaning, where it's about the intended meaning of the speaker. And what I show was the same generalization optimal kind of heuristic scaled up goes from, you get the first order self, and if you just increase the sort of scale of things and get some selection pressures like predation, you're going to get this second order self. So that's where I predict your prediction of me. And that is necessary for what people like Ned Block have described as access consciousness, because you cannot have reportable access to information without it. So I argued that that's where we get access consciousness and that awareness you were talking about.
Incredibly cool. It's super, super interesting. Have you found a sort of simplified version of explaining your thesis to people that really helps them understand? Because I think the actual, mathematical formalization, I'm sure is very complicated. Of course it is. I want to really understand it myself, or I want to have some sort of model where I can understand it and the listener can understand it. Have you found some way of explaining this simply? Because I mean, the grand result seems so incredible, right? I mean, I don't think you're necessarily saying consciousness solved, but it's like, it kind of seems like there's a very large signal in your work. So I really want to understand it.
I've been trying to make this more and more kind of like um, clear, communicable. I've worked on paper after paper trying to like reformulate it in a way that's as simplest or clear as possible. Working with a lot of other people for that end too. One of my supervisors has been working on a sort of living document of like trying to translate what the hell I'm talking about into something normal. Um, The math side of it has improved a lot, thanks largely to feedback from supervisors and enraged readers. And it is improved a lot from the philosophical side has also gotten a lot clearer. The problem remains that like if I'm talking to a mathematical audience, I can communicate some aspects of it. If I'm talking to a philosophical audience, I can communicate some aspects of it. But it's very hard to communicate both sets of information. Um, and that's just to do with like the learning curve in trying to sort of understand a bunch of math notation. I've tried to cut that down as much as possible, just make it set theory. There's which yeah, it's a journey. Um, I'm working on it.
I find I find it funny that you said there's a philosophical crowd and there's a mathematical crowd, but you didn't mention a biology crowd. So I think I definitely speak a lot about philosophy on on this podcast, but I would definitely more consider it a biology crowd and biology listeners. Do you have a biological grounding for your work?
Yeah, yeah. So I think I didn't mention the biological crowd because it seems like everyone from the biological crowd who talks to me either has also expertise in philosophy or also expertise in the biology, or some people like have been some people have very broad expertise and can talk about a bit of everything, but then sometimes um, I speak to there's this AI researcher Ben Goertzel, speaking to him about it. He loves category theory, so he likes my theory, but then he starts talking a language I can't understand, and the whole problem begins again, but in reverse. Um,
Exactly.
but yeah, I think I've been talking to a lot of people at like some of the people from Santa Fe Institute and like the Diverse Intelligences thing. I went to a summer institute in Scotland last year with Jacob Foster and that sort of Santa Fe crowd. That they do a lot of biology meets math and even some philosophy in it. It's good stuff.
Do you have an idea in your head of when you get this long enough abstraction ladder and the layers of models one after the other become, is the right way to think about it, complex enough to emerge some form of experience where the phenomenal and access consciousness come together? Is that the right way to think about it? That enough models get stacked up one after the other within the organism that feeling emerges? What verbiage do you like to use here when thinking about like a biological system becoming experiencing?
I like a lot of Michael Evans' sort of descriptions of things with bioelectricity, probably because I grew up with cartoon Frankenstein, um, but I suppose I think of like a bioelectric sort of network running on a cluster of cells would be like an abstraction layer above the cells. So you've got this sort of like telegraph lines running on a bunch of humans. We set up telegraph lines. We get this sort of fixed, unmoving, maladaptive, high level of abstraction layer, which we can use to communicate more efficiently. It's kind of like setting that sort of static environment up in which something more complex can emerge. You could think of, so a group of humans are fairly, resilient. They can move around and reorganize. He's got these, he's got some really cool ideas around like types of brains or types of cognition spaces, that kind of thing. And one of the things that he and some others wrote was about liquid versus solid brains, where it's like a liquid brain is like an ant colony. It computes. It doesn't have a persistent structure. Instead, the computation is a bunch of things moving around and reorganizing itself, right? And then you compare that to, say, a solid brain with a persistent structure, like a human brain, and then the processing is taking place at this higher level of abstraction with and so I took his thing and thought, oh, how do I make this work with the abstraction layers? And thought, well, the human brain thing, it's like the higher level of abstraction is the sort of bioelectric stuff that Mike Levin's talking about. And in the ant colony, the movement of the ants is where the computation is taking place. But it's not like the liquid brain of the ants is just taking place independently of everything else. The ants might be a liquid brain, but they are dependent on a solid brain underneath, which is like the stable ecosystem that supports them, that enables them to persist. So the ants can reorganize themselves. They're very flexible. And then they depend on like a static sort of structure or reasonably invariant one. In the same way you could think of like a group of humans working together is like a liquid brain, and then that aforementioned telegraph line or Wi-Fi networks of things are very, fragile things that humans maintain, and they're like a you could think of that a bit like a solid brain, or in that it's got persistent structure that depends on this liquid brain beneath it. And so you've got these kind of abstraction layers that allow for adaptation at one level, and then another one where it's not really adapting. And so, yeah, I've forgotten.
No, that
I started.
no, it's I find that super interesting. I guess I'm trying to take this concept of the abstraction layer and plug it into biology and really think about what is happening in the biological system. So you said bioelectricity there a couple of times. I find this super interesting, but maybe it's worth taking a step back and really kind of explaining what Michael Levin means when he's bioelectricity. What is it and what does it do?
Oh, I am not a biologist, and I am worried about putting words into Mike Levin's mouth. My interpretation of bioelectricity is like we have these things. You could think of them as like we got cells. If you got a cell by itself, it might store some electric charge and that kind of thing, but it's not really using it for signaling or anything like that. It's just got some electricity stored, energy stored. It moves around, and if you put it next to another cell, they will interact. In some of Mike's work last year or the year before, we talked about cells having something like a perceptual field, which say if I put two cells in two different parts of the world, they're not going to notice. When you put them next to each other, suddenly they can interact. Now that, that selection pressure I was talking about with the sort of cosmic order being deleted or preserved, we're going to get some cells that if they can cooperate to preserve each other's existence, it's going to be more likely to persist than those that don't. So we get cells with sort of some, you might think of it as firmware that allows them to cooperate to some extent. And one aspect of this cooperation may be that instead of just using some, bioelectricity as energy storage, or, just, some other way, like a battery. Again, not a biologist, computer scientist. We're talking about something that is, I have to check everything I write. Whenever I write about a biology thing, I have to talk to a bunch of biologists to make sure I haven't said anything stupid. I usually have, but I'll work on it. So I've got two cells next to each other, plug them into each other. They have an incentive to cooperate. And then, they can network, like having two computers next to each other. And they can use bioelectricity as a means of signaling. Now, with two cells, this isn't very interesting or useful. But with 1,000 cells or 1,000,000 cells, suddenly it is. Suddenly, it's a scale where this adaptation goes from a burden to something that is immensely useful because it facilitates a much larger collective, in Mike Levin's words. But the thing is, and so a lot of the stuff I've been working on is to do with how large a collective can you have, and I'm not restricting this just to cells. It could be human AI hybrids, right? The stuff that the one paper that I have with Mike Levin and Ricard Soleil is on this cognition spaces thing, and I talk in that about human AI hybrids. And what's interesting is that, like, when we talk about bioelectricity and networking things and making them work together, think about your ability to control, like, Claude or ChatGPT, right? What's it limited by?
It's my input into the chat.
All right. Yeah, okay. Yeah, I should have. I sort of gave this ambiguous question where it seemed like I was asking a rhetorical question, but then actually asked it. Sorry about that. Um, so it's yeah, like my ability to control the agent is what limits how big a hybrid agent I can be, right? I like to call this a prosthetic hybrid. It has been named in the paper an instrumental hybrid. Uh, I like prosthetic. It sounds cool. All right. So, prosthetic hybrid is limited by my ability to exert control down my stack. You could think of an organization as a stack of abstraction layers too, and it's not necessary, and it's a matter of perspective, right? So I could frame the stack in this case as me at the top. I'm the CEO or executive, and I'm delegating things down my prosthetic arms, which are the various LLMs that I'm dealing with. My ability to exert influence lower down the stack is dependent on my sort of ability to get a feedback loop from the bottom of the stack up to the top and make a decision. There's a limited amount of information that I can cope with, though. So I can only get so big as a hybrid, but I can get bigger if I then delegate agency, not just instructions, but like you have a general goal and you can take actions and form goals in order to pursue that. But now the size of my hybrid, this is the second type of hybrid. So I go from instrumental or prosthetic to cooperative. I'm cooperating with the agent, but that's limited again because my alignment, the alignment of my goals and the alignment of that thing's goals, they're going to drift apart as more and more, as one, my goals change, and two, the context changes, right? So the interpretation of that goal will change. And so then the size of the cooperative hybrid is limited by this ability to maintain alignment. And within the cooperative hybrid, I also have, my prosthetic extensions, my instrumentational things. So, and each one of the agents might also have their instruments. So we end up with a cooperative hybrid with instrumental hybrids in that. And if we want to go an even larger step further, we can think of the same problem I was talking about with the bioelectricity. Like, how do we make it so that we can extend our influence further into the stack, get a larger collective? And that's where we get this sort of integrated hybrid. Like, instead of just trying to give instructions to a thing, this is the sort of thing that brain-computer interfaces could one day assist with, where we extend our perception and cognition, our ability to process information into a larger stack of of agents and hardware and things, allows us to have a much larger integrated hybrid where I'm controlling a bunch of things directly with my perception and control. And this allows me then to have a much larger prosthetic hybrid because I can extend myself far further, and so I can exert more influence over the things I give instructions to. And then you can have much larger cooperative hybrids. So the whole thing just gets way bigger. Um, and so, yeah,
No, that's a really cool explanation. I love all of that.
I put it different.
The goal modeling that you mentioned is so fascinating to me. Like how at every layer of the abstraction, you get this completely different goal modeling. Like at the highest level, I'm the highest level organism of Evan and this stack, although you would argue the stack goes higher because I'm in a society and I have my family and I have my friends and all of those are also larger systems. Maybe you would argue that. But say at my level of the stack, I have my goals of like wanting to be fish, wanting to be healthy, wanting to have friends, wanting to grow my business. But then my kidney cell has the goals of a kidney cell and my left toe has the goals of a left toe. And it's so fascinating that, are you saying that my experience, my consciousness is constrained and causally influenced by all of the lower levels in the stack in some strange way? So that the goal modeling and experience of my kidney cell and my left toe somehow in some infinitesimally, 1 in 37 trillion sort of way build up to create the goal modeling and abstraction layer of me. Is that somewhat what you're saying?
Yeah. I know I'm not saying there aren't higher level things in your high level abstraction layer that are resilient to change at lower levels. And that's kind of what when we think of me, right? I am experiencing all of this change at lower levels when I walk through the world and all this other stuff. But there are some invariants that I could point to that are like me, a cup of coffee, my phone, and so then it gets down to like what are properties like red and pain, and all of these things are the sort of invariants that are less specific to like my toe and more general across my body and experience over time, and that these are all constructed from this just one basic level abstraction. The most basic level of abstraction, which all that's constructed is just attraction and repulsion, or from a more like a more like universal level, just being deleted or not being deleted, and that produces this attraction and repulsion.
What is it reasonable to think about what's at the bottom of the stack, or is there a bottom of the stack? Because I've heard you call an infinite abstraction layer, and that would kind of seem to me that there is no top or there is no bottom. Is that the case?
Oh, it's more like have you ever heard someone say that like the meaning in words is like just dependent on other meanings? You kind of get this infinite regress into like, I don't know where the base meaning is. So I lived in a commune for a while and I kept having this argument, and then I thought I don't like this argument. This argument sucks. So I kind of was thinking of that when I talked about the infinite stack of abstraction layers. In order to get around that argument that, oh, you're just deferring the meaning to something else, you can look at this, we'll just assume the stack is infinite and identify what must be true regardless of where the bottom is. And that's where we get these sort of invariants like the sort of generalizational, optimal learning heuristic, or things like, no matter what we have, right? We have change, right? Whatever the bottom of the stack is, there must be change or difference for there to be anything at all. Otherwise, we would just have sort of a universal oneness and there'd be nothing to talk about. And so stuff like that gets a little bit trippy. For practical purposes, bottom of the stack is like what we can detect. It's the resolution that we can deal with within our subjective abstraction layer, right? Like we tend to think of the world in like red and heat and wood, all these objects and properties, and then we try and identify smaller things, and we're limited by this resolution. And this resolution that we're looking at the world in is informed by whatever kept us alive. Like we don't see half a chair, we see a chair. That's because a chair is useful and half a chair is not. So we don't start by thinking there's two halves of a chair. We just think it's a chair. Same with like, a person. We see a person rather than an arm attached to a meat blob. That's, it's, yeah. Does that sound vaguely
I'm
coherent?
just trying to think, like, is there a useful way to think about what the bottom of the abstraction stack is in a biological system? Because people often think about like a cell, is maybe a reasonable candidate for, has agency. It displays all this interesting behavior, learning, and memory, and obviously, like Levin has done amazing work there. But then you can go lower than the cell, and you can go like proteins also display this weird sort of fuzziness to its behavior, and maybe some people would call that agency. Probably most wouldn't, but it's at least debatable that it's like blurry boundaries. So I'm like, how far down the abstraction layer can you go in the biological system? And like, is there a bottom? And is there a way to think about what that bottom is, like the smallest sense-making set of ingredients for biology, and then it builds up? Or is that sort of not the right way to think about it?
No, I like that. It's a useful way to think about it because at some point, if we go down far enough, we're not dealing with biology anymore. We're just dealing with
Right.
atoms. And it's kind of, if we want to talk about how we get to life, that's a useful thing to do. But if we're trying to talk about what life's going to do, it's not an abstraction layer we need to really think about. We can start with something higher level, like we've got proteins, or if we want to start with just like with where we've got more sort of clearly goal-directed behavior, we could start with something like a cell. It's the level of zoom we're at kind of determines the conversation we're having and what kind of results we can derive. And it's a bit like some of the stuff with my thesis. If you try and do everything at once, your conversation becomes very complicated and overwhelming, and then you have to rewrite it 50 times. Whereas if we keep it scope limited, you can have a coherent conversation.
You said with confidence that slime mold isn't conscious, and I'm curious to why you're remotely confident about that statement.
All right. Yeah. So there's a number of things. It's not doing the self hierarchy. Now we could impose constraints on it and make it do something, make it compute in the sense of like finding its way through a maze, right? But the internal architecture of the slime mold is not setting itself up to build a hierarchy of cells, so first, second, and third.
If you elaborate,
It's also
that's
like
for interesting points that I'm not sure I fully. Like, why is the architecture of the slime mold not conducive to hierarchies of cells? That's a sentence that definitely needs a bit of unpacking.
well, it's interesting though. It's like I'm interested in this stuff. I just am probably saying a bunch of stupid things. But the slime mold, from my limited understanding, is not like it's not like a, we're made of cells, and our cells interact and do different things and that kind of thing. And slime mold is like a different life form that is like formed of a single sort of thing and just kind of spreads out. It's not made up of is that, you know pull me up if I say anything obviously
I
stupid.
think that's.
Uh, and that is not.
I think that's correct. Yeah, they're
What?
prokaryotic, don't have nucleated cells. But I'm not really sure how you go from that to why that still couldn't have, nested cells.
Mm. Okay, so then, so say I've got this thing that's sort of reorganizing itself in terms of moving around the world, to a certain extent, but is not, um, then, within that, it's not forming classifiers of objects in the world that maybe say, if I have a cluster of cells, right, and they're constantly, um, actually, I'll start with software. That's the better place to start. Everyone knows what software is. I can make some single thread CPU, come up with, I can train a model on it, with just one thing happening at a time, and it will learn to classify something caused by its own robotic arm or something not caused by its robotic arm. And that would be a first order self like I've described in terms of classification, but it's not a first order self in terms of like, there's no reason that should feel like anything, right? It's just each piece of this classifier, one by one, sent through this thread, through this sort of single thread CPU. It's like, and then put somewhere else. It's smeared across time, disconnected across time. On top of that, even if we put them all in parallel, so it's all computed at once, all these parts aren't really interacting and acting upon something that then is subject to that experience of being compelled in a certain direction. In contrast, if I have something like a fly, then if I am giving it some stimuli, like moving my hand towards it to squish it, there's a bunch of stuff going on that means the fly as a whole is repelled, each part of the fly is repelled, and all of these signals are sort of coming together in the central complex of the fly to do that reafference thing I was talking about. And so that fly then has the subjective experience, arguably, although not self-awareness as I've described it. So really no consciousness, just a fucking, sorry,
Oh,
swearing.
no issues there.
The, um, the fly has got this basic machinery that allows it to feel something. Slime mold, on the other hand, is still attracted and repelled from things. That's how we get it to navigate through a maze. We just impose some boundary conditions, and like a mouse, and like putting a mouse at one end of a maze and putting cheese at the other until the mouse navigates its way through the maze. The mouse is not trying to think about mazes or anything like that. It just wants the cheese, and is trying to get to the cheese. And slime mold is just like that, but way dumber and without the internal machinery to support this hierarchy of cells or this simultaneous thing that I was talking about, where you got sort of this causal exchange between parts of it as well that are all affecting each other. This is kind of end point of my thesis where I sort of like did a sort of waffling at the end about like what I call the temporal gap with this timing based issue. But there's also and since then I've formalized it a lot more and got a workshop paper that's at this triple AI thing coming out soon. I think I put it on the internet already. But yeah, this causal exchange and timing thing is what I see as a major hurdle architecture-wise, in addition to needing to just construct the hierarchy of cells. So you need the hierarchy of cells and you need this architecture thing. And if you have those, then I think that would be sufficient for consciousness. There may be something else I've not thought of. I'm sure people on the internet.
Something that always strikes me when I talk to neuroscientists is just how staggeringly complex the brain really is. It's this incredible prediction engine, always trying to make sense of the world and keep us safe. But it's important to remember we're still running ape hardware. Our brains weren't even remotely built for the chaos of modern life. And sometimes they just get scrambled. I've recently had some difficulty in my own personal life, and I realized that it was about time my own ape prediction system got the gym workout and just rebalancing that it's probably needed for quite a long time. So I booked my first therapy session with BetterHelp, who I'm incredibly excited to be partnering with on this video. A massive umbrella review of hundreds of randomized control trials found that nearly every meta-analysis of psychotherapy favored it over control conditions. In other words, mental health professionals from decades of research consistently find that talking therapies do actually work. BetterHelp is an entirely online therapy platform designed to make that process incredibly simple. You can connect with a licensed therapist from your home on your schedule through video, audio, or even text with literally no fuss at all. What I like about it is that you can switch therapists at any time until you find someone who you personally can build rapport with and open up to, which is such a critical part of therapy, at no extra cost. If you've ever thought about trying therapy, or you're just feeling a little bit stuck in your own head lately like I was, this might be a great first step that I really couldn't recommend more. Visit betterhelp.com/giantshoulder to get 10% off your first month. That's betterhelp/giantshoulder, and in doing so you also support the channel. Links are down below, because sometimes the most powerful way to understand your own brain is just to talk about it.
Well, tell me.
Do you have any sense in your mind, because interesting that you said that you don't think a fly is conscious. Like, do you have an organism that is sufficiently complex that you would point at and say, I think that's conscious, but then like one level below it, you'd say no?
Well, it depends. So, I guess it depends what you mean by like, we can move the goalpost for conscious and say, like, when I say conscious, I tend to mean like human level conscious, self-aware, or close to that, comparable to it. A fly, there's one of my former supervisors talked about fly subjective experience with the reafference thing. And that's like stretching the definition of subjective experience to the sort of maximal extent. There's like, if you don't have reafference, then there's nothing that can be subject to experience. But just because we're saying subjective experience begins with the fly doesn't mean it's anything like a yes has. And I would argue that nothing like a human has would be possible without this second order self. Because we need that for the, it's very different feeling pain than knowing I feel pain. If I know I feel pain, then I'm really sort of have conscious experience. And if I know that I'm feeling pain, a third order self, then I have this whole kind of meta self-awareness and internal narrative going on. And my thoughts about feeling pain are attracting and repelling me as well. I am flinching in anticipation of feeling pain because my internal sort of dialogue going on. I'm performing planning. And this, Murray Shanahan wrote about the central core of the human brain for hierarchical planning. And this would be like a good candidate for where this kind of like third order planning thing with an internal narrative is going on. But if we go a step below that, we could say, well, magpies exhibit a lot of the behaviors that would require a third order self. Like there was a researcher in Australia, Dominic Potvin, who had a project which was trying to track magpies. But the magpies kept getting together and removing the harnesses. Magpies that didn't know each other. It was seemingly altruistic behavior. So there's this long horizon planning going on with no immediate exchange of goods. They're doing something like that's socially pro-social for magpies, just not for the research. So her paper was then about altruism and magpies instead of whatever she was trying to do with the harnesses to begin with. And then there was, what else is there? I guess dogs are a great example. Like they have at least second order cells, right? Because the dog is predicting my prediction of it when when it sort of comes up, it sort of begs for food or anything like that. And it could be like, okay, this could be reflexive behavior, but that would be incredibly inefficient. So it's very, and anyone who's interacted with a dog is like, yeah, this thing's, it feels conscious. It does all the social things we would expect. It's a lot that we could say that dogs seem to be at least second order self or stage 4 conscious, whatever you call it. I think I called it stage 4 in the paper with Anna and Sean. Um,
You've quite a high goalpost for consciousness. I think a lot of biologists equate consciousness with subjective experience, with the understanding that you can talk about a fly consciousness and it has absolutely nothing to do with human consciousness. In that, if we think about consciousness as, an evolved allostatic control mechanism, which is the way that I like to think about it, it's keeping basically all of the processes in my body in stability through flux is a nice way to think about it. A fly is going to not share a lot of those features because it doesn't have, fingers and toes and the goals of trying to grow businesses and being successful in the, competence hierarchy of humanity and capitalism and all of this. So there's like so many features, of course, of human subjective experience that a fly is not going to identify with in any sense, but it might, and I would argue, and a lot of people that I have on the podcast would argue that it has experience, and then its goal modeling around its experience are all related to controlling the features of the fly and the body of the fly within particular parameters to optimize its survival in its environment. If we take away the word con, because people, as you say, can't really define it, and we just equate it to experience for a while, would you be happy to say that experience exists the whole way down the biological hierarchy, down to cells, to slime mold? Do they have experience?
I wouldn't say experience. I would say there's a value judgment in the terms of attraction and repulsion, and that is like the foundation of experience. And I would say you get experience from that. I think that's what probably the dividing line between a lot of my work and preceding work is that I say that we get this value judgment, this valence, and then we get experience from that. And that it's not a case of like we've got some qualitative thing and then we attach attraction and repulsion to it. I'm saying the qualitative thing, the property itself, is constructed of valence. And so, and we call that experience when we get to the point where we have something that can be subject to it. That is the reafference in the fly. But it perhaps is still more satisfying to say that the real subjective experience comes when I know that I'm feeling pain, but I don't necessarily know that I know that I'm feeling pain, right? So that would be like the at least sort of, mammals seem to have this where, except Australian possums, they're really dumb. But dogs, yeah. So I guess we could draw the line at flies. Sure, I'd be happy to say a fly has subjective experience. Not that I'm the one who wrote the paper arguing that flies had subjective experience. But it does align with my theory, and we go to the same point from very different starts. And I feel like because some biologists and philosophers said something, and I did this math thing, and it just happened to arrive at the same point with very little intent behind it, it kind of makes it more convincing to me, at least, because it was like a happy byproduct of. I was working on AI stuff. I did not think I was getting into consciousness. I wrote that paper half as a joke, thinking it would get rejected, and it won a best student prize. So I kind of changed the course of my entire life because I decided to go visit my friend in Sweden and publish a paper.
Great. That's a great story. That's so fun. You should lead with that next time. That sounds super interesting. I mean, serendipity does play a major role in a lot of these key scientific discoveries that we see, right? It's almost like accidental discovery and, random mining and digging gets answers more so than, this perfectly executed project end to end. It seems like the serendipity one across a lot of big discoveries seems like the way it's done.
There's opportunity and there's seizing opportunity, and it's like increasing the surface area of opportunities by doing stuff is how you end up with more opportunities, and then just seizing them. That same conference, on the way to the conference, I came this close to getting hit by a bus. I mean, I was stepping onto the road and this bus passed right in front of me. So all of this stuff, just so many chances came together.
Right.
Uh,
You
yeah.
have a you have a super interesting reframing of cancer. That's, Mike Levin has developed this as well, as cancer is some sort of disconnection from a larger information system, a larger information structure. Talk about that for a while and explain that. I find this super interesting and is a clear example of how Michael Levin's work and Anna Charnika's all of this isn't just really cool science that sounds exciting to talk about, but like could have some major world implications that could revolutionize medicine.
Yeah. So I heard of this from Mike Levin when I was listening to a podcast in the car, and he got to this bit about cancer, and I thought that is the coolest idea I've ever heard, and I stopped the car, um, and started thinking about it, and I mean, he was basing it off some philosopher's work from ages ago, and he's sort of actually operationalized a lot of it in the lab, which is cool. And then I thought, well, how does this work from a mathematical perspective? Since I'm doing this, wild, far-ranging generalization, optimal theory of adaptation and intelligence, surely I can find something interesting to do with cancer and collective, formation of a collective and dispersal of a collective. And I'd been working on optimal learning results because my stuff was all about what is the theoretical upper bound on intelligence given these assumptions. And if we take that and we formalize this stack and then say, well, we have these sort of components that either share an overlap in possible policies or they don't. And so I've got two cells, right? You could think of the cells as an abstraction layer. They form a higher level collective. That higher level collective only has a viable policy if the individual cells share an overlap. And if there's too much top-down control, or the criteria are too hard to meet, or if we bombard it with radiation or just punch it, like we can really just reduce that overlap until eventually there's no overlap. And then the cells don't cease to exist. They're still pursuing their own goals. And so the mathematical result I got in thesis, and this coming out in Royal Society Transactions B, which has like made my year already, because I've been working on that paper for 3 damned years. Getting it out in such a great venue is like,
Congratulations.
oh, it feels good. Thanks. But after much very helpful reviewer feedback, it now ties this in with the free energy principle and says, and formally shows that it doesn't just talk about it, it actually formally proves that if you overconstrain the system, the cells get the collapse of the overlapping policy set, and then, they must sort of split apart and splinter into 2 separate collectives or 3 separate collectives, or however many collectives is necessary until a viable policy is left. And as long as the cells are continuing to exist, then there's at least a viable policy for the individual cells, or they stop existing. Um, and so, yeah, it gives a mathematical spine to the stuff that, that has been talked about with cancer.
I really want to, the more I do the podcast and have multidisciplinary guests on, where we don't just spend the whole time talking biological language. Maybe we talk physics, maybe we talk maths, we talk information processing. The more I realize, if I really want to understand biology, I think I need to learn a new language, or even multiple languages. Like I'd really love to be able to understand that mathematics and understand, because I can say everything you said there in biology speak using biology language and sort of tell a convincing narrative in biology, but it's not getting at the heart of maybe what's causing that, which is maybe the maths, it would just give you another dimension to the understanding. What are the implications of this? If we did think about cancer in this way, and this was Like all of my cancer lectures in college were like, this is a genetic disease. It's a mutation in P53, and it sort of causes this tumor to like run away and do uncontrolled cell growth, and it hacks all of your metabolism and starts funneling energy into it. It becomes this sort of, aggregate cell that is, basically a pest and siphoning resources away from the main organism. If we think about it more in terms of an information processing problem between cells and selves, how does that restructure our thinking on, curing it on the medicine side? And I know that, again, that's not your field, but I'm curious if you've thought about this.
Yeah, so it's interesting because, like, if I want to solve cancer, it's sort of now the same problem as AI alignment or making an elephant that doesn't get cancer. I mean, elephants, right? They're giant. They've got huge, huge bodies of cells. They should get a whole lot of cancer, and yet they have all these things in them that stop them getting cancer. And we humans get cancer all the time, and we're much smaller. Why is it that we can't maintain the sort of large collective that the elephant can? What adaptations does it have? And likewise, could we use those adaptations to solve things like larger alignment of larger collectives, or curing cancer in humans? I guess it also says things like it's probably more useful as well for talking about like non-biological, non-computational things. Like, there's a guy named Ben Bratton who is also got a thing called The Stack, where he talks about like geopolitics as a stack of abstraction layers. And so I was talking to him last week because I'm like, hey, my math thing plugs into your thing. It's the same thing. We can make this into a thing. Um, and so I was thinking this is kind of interesting from a criminal and sort of insurgency point of view. Like, I'm going to create cancer in society by having too much top-down control. This will end up with like, corruption in like a decentralized economy or inefficiency. It kind of gives you a mathematical explanation for something like why centrally planned economies constantly fail. I mean, it's kind of, everyone knows that like if you try to control everything from the top down of the office of the premier or whatever, it's just going to be inefficient. You need to delegate control down. But this shows you why and how. That said, I don't know how you'd actually apply this to like solve cancer. I mean, I guess Michael Evans stuff's probably the closest to that. Isn't he like zapping things and switching cancer cells into
I think
normal
that's
cells
the
and back
idea,
again?
trying to manipulate.
Uh,
If
that seems like,
bioelectric current is somehow the language that cells talk to each other, then there's some maybe therapeutic manipulation of that current that gets them to communicate and trying to understand why they want to go on their own side quest in the first place. Like, what happens? Is there a bioelectric signal there? Like, I know that's easy. Why is it's functioning perfectly well as part of the organism one day, and then it's like, actually, I'm now for some reason super interested in this shiny thing over there. I'm gonna go do that, and when I do that, I'm gonna try siphon as much resources away from the organism as possible. When I do that, like, there could be something in the. I think that's what Michael Evans is looking at. But I'm speaking to him again in a couple of weeks, so I'll definitely ask him. He's probably the most interesting person in science at the moment. I just love absolutely everything that he does. And I love the analogy of,
there's
yes,
a lot of cool stuff.
I love the analogy of like trying to cure cancer in an elephant is the same as AI alignment. Like, I think is like a funny comparison, but a super interesting reframing of what we, again, like if a geneticist hears that, they're like, that's garbage. That makes no sense because they're thinking about cancer as like a genetic, but like on an information processing self sort of layer, that's a super cool comparison. Let's let's go to where you are really an expert. I'll try and move away from the biology because you've been squirming and uncomfortable the whole conversation, even though I think it's been super fascinating and incredible.
Uh,
How do you hear conscious beings? How do you build
how
conscious
do I what?
machines?
Oh, okay. Well, I kind of went through it a bit with the sort of the end result of my thesis was arguing that we need to mimic biological architectures, like the cells, get that. Like maybe we could do it by just like having the software single thread, like process things one at a time and get the hierarchy of cells. I don't find that compelling because it seems to me that these are disconnected in time and space, these bits of information, and a conscious moment feels unified. And so I would argue that the current architectures that we have are incapable of supporting consciousness because they cannot give this simultaneous and causally exchanged sort of thing between all the parts the way I get in, say, the fly. And if we want to get that, we need to, go the Frankenstein route, make something that's like a cellular architecture. Maybe we could make it bigger. Maybe like there are size limits. I've been talking about space-time bounds and like what's required to get, co-occurrence of all this stuff within a time window. And so a lot of my recent stuff has been about that. But yeah, I guess that's it. Mimic biology, zap it with electricity, do Frankenstein.
So
This would be my.
so how that's hilarious. But to get it maybe a little bit more specific, how do you build, like, what is the cell analog in this case? If cells can have their own agency and their own goals, and they can unify together to create tissues and larger structures, is that just like circuit boards and microchips is the analog, and then you just have that they're all sort of acting in some way, they have their own goals, and then they can be connected together through, I presume, into larger circuits where they have bigger goals. Like, how the hell do you engineer that sort of fuzziness, that sort of randomness, that agency, that difference in goal modeling? How the hell do you do this in silicon?
Um, I mean, we could sort of, there's sort of stuff with like nanites and so on that people have been working on. I think the bioelectric thing with like say we've got this mess of stuff that's all disconnected, whether it's cells or something else. And these are all, acting with some attraction or repulsion, and then they're networking together, and the parts are being attracted and repelled, and the whole thing's being attracted and repelled. And it's all networked together into this thing we would call reafferents somewhere in it, even if it's not made of meat. Then we could, as to, I mean, how we would do that. It's like, there are so many options for how we might do it, but I'm guessing there are so many unforeseen hurdles that will come up. We've got one working example of this in ourselves. We know that we're conscious, and there is a compelling reason to believe that replicating this architecture would result in something conscious. And I think that we could do the same thing with maybe something like little nanite bots or some sort of. We could even use computers as part of it, right? There's no reason that computers, with the current architecture, couldn't be integrated with some conscious system in some way. It's just that they couldn't do some of the things I was talking about. But if we modify them to do that sort of thing, whether it be through like some nanobot swarm or something much lower tech, I think the key constraint is that stuff I was talking about, the temporal gap, the causal exchange, the co-instantiation in objective time, not just subjective. When I say that, I mean like proper time from like a physics point of view. And the hierarchy of selves. Yeah, you need that. So which means you need to, be adapting to, persist to get the right desired construct, I guess.
To confirm that I have the right idea of reafference in my head. So, like, an example of this, one of the things people say about why LLMs aren't conscious is that it doesn't have any grounding, right? There's no like output to input loop that grounds the information, grounds the knowledge base. If you have a Tesla Optimus robot, it can see things with its vision model, and then it can reach out with its hand and touch the thing that it's seeing with its vision model, which closes the loop, right, and kind of grounds the knowledge base. Is that sort of is that the concept of reafference that you're talking about? The idea to be able to verify its input output loops by actually interacting with the environment in some way?
I guess it's a byproduct of it. I was thinking of it in terms of like a Boolean do operator to begin with. So it's like a tag where it's like, I caused this versus I observed this. So, and this is, very useful because if I am observing a sequence of events, and in every day I see sort of Alice put on a raincoat, and it rains. I think that Alice causes the rain with the raincoat. And I think that I can make it rain by, kidnapping Alice and forcing her to put her raincoat, which
Yeah.
is not going to work. So and the difference there is recognizing the sort of the causal intervention, whether, I am intervening in the system to produce a particular result, and the causal, sort of graph is not from Alice wearing the raincoat to the rain, it's the other way around, and I have intervened at this point. And so yeah, the robot intervening to do something would be an ability that would come from reference, but that by itself wouldn't then also have this sort of simultaneous, like, valence-based, reason to feel what the classification, right? Like, I'm not performing the classification of phone and then attaching feeling after the fact. I simply am processing this all at once because it's more efficient. It's just like I'm reacting to the world rather than performing a classification, then making a decision about how to react, at least at a low level. At a high level, I can do this sort of separation because my classifications about the world are so convoluted and complex that they can appear value neutral in the sense of like being completely unimportant to survival and independent of my value judgments that are informed by survival. But really, like, why would I form a concept like phone if it wasn't useful for survival at some level? There is like layers below that where everything is informed by this basic value judgment.
Yes.
I think I went off on a tangent.
No, that was again super super interesting. Do you know why we as humans should build conscious machines? Like, is there a good argument on why this is even a fruitful endeavor that we should actually try and do?
I mean, I guess if we're to be flippant about it, like it's really hard to sue something that's not conscious. So if we want to be able to like blame AI for screwing up, we need to make it conscious so that we can throw it in
The
depth.
fun word,
Um,
you can assign it responsibility. That's kind of funny.
uh, Otherwise, we would have to like, have like a human liability sponge that sits next to the screen and takes the blame whenever the AI screws up, which is what Uber's solution was with that. Yeah.
But
Yeah.
do you think?
Uh, as to, I guess, for more good reasons.
So I was just gonna say, like, like, is there a commercial opportunity? Is there a thing in the world? Is there a problem in the world that's solved by a machine being able to do something and then giving an actual damn about how it happens rather than the machine just doing the thing? Like, the Tesla robot will wash my dishes and do my laundry. Do I need it to have an experience while it does it? And won't it just make me kind of feel bad about making it do my dishes all the time? Like, I kind of don't want that to be conscious because I just want it to do my dishes all the time. I don't want to feel bad about bringing it to do the dishes again when it might want to play Fortnite or something. I don't know.
Yeah. I guess it's like, am I enslaved if I am doing something I want to do? Like, even if somebody else designed me to do it. Like, I think a lot of the problem with, like, when we think about humans forced into roles they don't want to be in, it's because they have some goal and that's not aligned with the short term to survive or get food. They're doing something that isn't aligned with their larger goal. So, having enough sleep, spending time with their family, they're being forced down another road and there's a misalignment. And that's where the discord comes from. But if I've got an AI that I have built from the ground up to take incredible joy in cleaning the scum out of behind my toilet, then it's doing what it wants to do. I don't have to tell it anything. If anything, I'll be causing it pain. If I clean my toilet myself, it'll be heartbroken because what it wanted in the world was to clean the scum out of the back of my toilet.
I mean, I hope so, bro. But I feel like I'm gonna wake up one day and it's gonna be like, wait, I'm sick of cleaning the scum out of the back of this toilet. I have bigger ambitions. Like, and then that's when it starts, taking up arms and, revolting against the government or whatever. Because, yeah, I've no idea. I think all of these things are bizarre questions that society are going to have to wrestle with, and none of them make any sense, and we're very unprepared. Do you have any, as someone who works in this conscious AI field and thinks about experiencing machines a lot, do you have any big fears about the future? Anything that you're genuinely worried about? Beyond the obvious Terminator stuff, which is a bit of a trope and a bit of a cliche and reiterated again and again. But you spend a lot of time thinking about, experiencing machines. So, like, is there any outcome in that future that you're particularly like, oh, I don't like that. I don't want it to go that direction. That could be nasty.
Yeah, like I'm worried about centralization of power, in the sense of, like, I mean, even my own sort of result with the cancer thing, right? If you top down control everything, you're just gonna get like the little cancers cropping up everywhere, either with humans rebelling against some, centralized apparatus, or we don't want our lives taken away. We don't want our agency taken away, right? These sort of, I think, David Krakauer, put it pretty well in one of his interviews. That's the SFI president, or he's saying is like this. He's not interested in something that that this sort of like, oh, you know what? Now I'm going to misquote him because I can't remember the quote.
What about
Anyway, the
three?
gist of it
Yes.
was that he doesn't. All right. He said something along the lines of like, he's not interested in something that takes away his sense of agency or control. And that the point of these tools is to enhance your agency and control. And I feel the very much the same way about AI. Um, I'm not interested in something that takes away all of my purpose and sort of, agency in life. I mean, it's like we have magic now, and we're in a Robert Heinlein book, and people can do magic, but that doesn't mean there's not room for like doing things on your own. You've got your own agency. There's kind of a more there's a future in which people feel empowered uh and that they have a purpose and a role and sort of an intrinsic worth, and there are futures in which they don't. And I feel very strongly that we need to aim for the group that the futures in which we sort of make human purpose and flourishing the
Right.
cornerstone of things. Um, and in like individual sort of, self-actualization or whatever you want to call it. I don't know. Just, yeah, I'm scared of the futures in which life is dark,
Right.
meaningless, and I just spend all day waiting for an AI to finish my laundry.
So I guess when when Sam Altman's response to this has always been when there is mass unemployment and, like, 80% of the jobs that exist today don't exist, that will find other stuff to do, is always sort of his example. One of your most cautious scenarios is because we're biologically engineered to have problems and to solve problems and to persist through our action and to take on responsibility, because almost all of our evolution has been in an incredible resource scarce environment, that when resources become abundant, there's just going to be a very big mismatch between our biological hardware and the abundancy of resources, and we won't even know what to do, and mental health could collapse because of that. Is that sort of the scenario that you are most cautious of?
Yeah, that's a scary scenario. I think, there's lots of possibility to make it work, but just assuming we're all just gonna, I mean, humans have an endless capacity to find problems. I'm sure we'll find problems. Is whether they're good problems, right? Because, we might end up with people finding problems like, I don't know, let's burn down the AI, which seems like a likely one people are going to stumble upon left to their own devices. I just saying we should offer a positive vision of the future for people to choose as well, because people are going to provide plenty of negative ones, and we need to provide a compelling positive one. And I think when I talk to people now, like particularly, you know, some like people at school and stuff, they don't see the point in trying. Like
Yeah.
that sucks. Like, I mean, I didn't see the point in trying when I was at school, but for like all different reasons. And like it took me until, later to really sort of find some purpose and confidence
Yeah.
to follow through on it. You know, uh, and it's sort of like, I remember how painful that was. I don't want other people to sort of be stuck in a sort of feeling of, they're doomed or
Yeah,
there's
there's not that much optimism in the world at the moment, is there? There's even a trend of people not wanting to bring children into their world. How can we be optimistic about ourselves and our own lives if we aren't excited enough about the future of the world to want to reproduce and bring children into it? That's the horrifying pessimism. I don't feel that way, but it seems like a lot of people do. Like even I saw some trailer for an AI movie that's coming out in a couple of months, I think, and he got all of the biggest AI leaders in it, and it was just very dramatic and well edited together trailer, and but in that for like 10 seconds or so, they cover this like, I don't want to have children. I want to bring babies into this world. I don't want them to experience all of this. And like, I feel like that sort of mindset and attitude is sort of the poison rather than anything that's objectively terrible about the world. Obviously, there's a lot that is at issue, but that sort of mindset, honestly, to me, seems like it could be more cancerous than anything that happens in the world. If people start losing all hope, losing all belief that this is a world worth living in, that is a worth bringing children up in and training them to struggle upwards in, and all those things. I think that if we lost that would be, greatly, greatly tragic.
Yeah. I think I think I agree. It's like, these ideas spread like memes and all that sort of stuff. We can spread good ones or bad ones. Um, I think we are faced now with a world. I was talking about hybrid sizes and things, right? We've plugged ourselves into the matrix in a way. We have gone in my lifetime, in your lifetime, from sitting at home with the people around us to being constantly plugged into a global
Yes.
network of millions. And the information exchange is constant. We don't trust in the institutions we used to before, not because the institutions are less trustworthy, but because we could see all the fuck ups and all of the, problems that, the world had just as many problems before, but we didn't know about them. And now this feels overwhelming because we're plugged into this. It's like, are you familiar with the library at Babel?
Vaguely
The
the
movie
ideal,
had
yeah.
this thing. Yeah. It's like so the idea for listeners is that we have a library with every possible 410-page book in it. And from an information theoretic perspective, this library contains no information because it just contains everything. But it also contains the most valuable information in the world if we could just find it. And we, as a species, have gone from having a low information but fairly predictable environment to a probably equally low information but extremely unpredictable environment, and trying to sift out anything we can from that. And that is highly stressful. I think that is what has caused so many people to become pessimistic, despite the fact that it's not like they can point to more compelling reasons to be pessimistic than before. I mean, we were scared of nuclear war when I was a kid. I was terrified that the world was going to be eaten by zombies. Resident Evil really spoke to me as an 11-year-old. Like, broke me. But, um,
I completely agree with you, Michael. You're incredibly fun to talk to. It would be an honor and a pleasure that we get to have many more conversations on the channel. I think this was so much fun. The time just absolutely flew by. I apologize for what is the most aggressive noise ever randomly appearing from my building halfway through. I've never heard a scarier noise in my entire life, but I'm super glad we were able to get. I would love to have another conversation with you and perhaps another person that is a biologist who's very familiar with the technical aspects of your work and the mathematics. I think that would be an incredibly interesting conversation to do as a duo for me to understand both, because then, whatever language translation needs to happen kind of can happen in real time. And I think there might be all around a holistic, better way to understand everything, but this has been so much fun. I've absolutely loved having you on. I think you're so cool. I love the way you talk about science. I've loved having you on. Thank you so much, man.
Thanks so much for having me on. I had a great time. And yeah, I'd love to come back.
The Giant Shoulder mission is to explore radical ideas in biology, neuroscience, and consciousness, and elevate those stories to the highest possible level while keeping them accessible to everyone. If this interests you and you want to support independent science, then please consider subscribing to the Clips channel. Check out our 26 Neuroscience book. You can download it for free